Now we'll start with one trick which will very easy for you for learning of electronic configuration. So trick for electronic configuration. With this trick it will very easy for you to learn electronic configuration. If you have confusion which subshell you will fill first and which one later on, then it will very easy for you to learn with this trick. That is school, public school, daisy, public school, Fadu Daisy Public School, means school, public school, Daisy Public School, Fadu Daisy Public School. So before this you should learn ki in S subshell how many electrons you can fill. 2. In P maximum 6 electrons can accommodate. In D it can accommodate maximum 10 electrons, and F can accommodate maximum 14 electrons. This you have to keep in your mind. Now we'll start. S orbital starts with 1. P cannot start from 1p because 1p it's not exist. It's start with 2p. Similarly D starts with 3 and F starts with 4. So we will give numbering to S orbital first. I have written here 1s, then I'll write in increasing order. First for S only, 1s, 2s, 3s, 4s, means you have to give number like this कि in each next line if S orbital is there you will write it in increasing number. Like I have started with the first line, I have given number 1, then to the next S, 2s, it's 3s, it's 4s. Now in next line it's 5s, this one is 6s, this one is now 7s, this one is 8s. Now next with P, 2p, it's now 3p, it's 4p, it's 5p, it's 6p, and it's 7p. Next is D. I have written here 3D. Now this one is 4D, 5D, 6D. Now we'll start with F. In these line nowhere I have written F, in last line only it's a 4F and this one is 5F. It's a very easy and simple trick. You can easily learn which orbital will first. Now see here, it's 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 5d, 4f, then 5d, 6p, 7s, 5f, 6d, 7p, and 8s. It's more than sufficient enough if you will learn this much of electronic configuration for your CBSE exams also and for your NEET and JEE exam also. Next is, it's also a short method which you have done in your class lecture also. I have written here periods are 7 and period number I have written here 1 to 7. Value of n is n, I have written from 1 2 3 4 5 6 7. Then subshell being filled, if number 1 is there it means 1s subshell will fill. First element is hydrogen and last element is helium, and if only one S subshell is present, so total number of elements or electrons present are only 2, so it's 2. And the next is second period, number of orbitals or subshells which will fill is 2s and 2p. First element is lithium, last is neon, and number of elements are 2 plus 6, 8. Same way I have written for 7 periods, which one is the first element, which one is the last element, and how many number of elements are present in first period 2, second 8, then 8, 18, 18, 32, 32, and these are called as magic numbers, which I have given in MCQs. So I hope it's clear to everyone. If you are having any doubt, any time you can call me or you can WhatsApp me. I'll give you answer. As last time maximum of you have asked questions from your MCQ. It's very good. So now we'll start with journal electronic configuration for coinage metals, coinage family. Coinage family or coinage metals are which one? That is copper, zinc and mercury, and that belongs to D group. So I have written here journal configuration for D block elements are N-1 D 1 to 10 NS0 to 2. So we'll write configuration for coinage family, that is argon 18 3D10 4S1, because it's exceptional configuration in which fully filled configuration is more stable. So that's why I have written here 3D10, and this one is noble gas configuration, that is argon 18 3D10 18 and 10 are 28 and 1 is 29. So that is exceptional configuration for copper, whose atomic number is 29. Now we will start with next topic, that is how we can locate any element in the periodic table, means location of element in periodic table. So you need to follow certain steps. From that steps it will very easy for you that you can identify a particular element in at particular place in periodic table, means it's present at which period and at which group. So step 1, you have to write the configuration of the element. For example, I have taken here atomic number 31. For that 31 you have to write electronic configuration. I have written here 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p1, or you can write short form also, means till 1s2, 3p. It's having noble gas configuration till here. So we can write how it is. It's 2 into 4, 4 and 6 10, 2 12 and 6 18. So 18 is argon, that is we can write like this way also, that argon 18, 4s2, 3d10, 4p1. Now we'll count 18 and 2 20, 20 and 10 and 1 31. So we have to write configuration for 31. So in first step we have written configuration. Now in second step we have to tell it belongs to which group. So the subshell in which last electron enter, that give the block of the element. Now you can see here very well that last electron enter into P block, that means it is P block element. So we'll write block is P. Step 3 for period, the highest value of N in configuration gives period number. So in this here, which one is the highest number, that is 1 2 3 4, which one is the highest number? Obviously this 4, so it belongs to period number 4. If it belongs to 1s, so it is period number 1. If it belongs to 2 3, then they must be having period number 2 3. But in this, because that is 31, so last electron enter into P block and it's 4p, so that's why period is 4th. Next one, if you have to find out group also, so for groups, if it belongs to S block, that will confirm from the last electron it enter into which block, so that will give us block group number. So if it's of S block element, then group number is equal to number of NS electrons present. For example, if in S block only 1 electron is present, then that element belongs to first group. And if 2 electrons are present in S block, S or subshell, so it's of second group element. for example, if it's lithium, atomic number is 3, so configuration is 1s2 2s1. So which block is there? Because last electron enter into s block, so it means it is s block element. Now it's confirmed that it is s block element. Now we'll see in s block how many number of electrons are present. It's having 1 electron, so it means it's a first group element. If suppose in case of beryllium, atomic number is 4, its configuration is 1s2 2s2. Now you can see here in s subshell how many number of electrons are there, 2, so that means it belongs to group 2 in case of s block elements. Now second is, if element belongs to p block, then it is equal to 12 plus number of p electrons. 12 plus number of p electrons, because why I have written here 12, because s having 2 electrons and p having how many number of electrons? It's having 6 electrons, and d having 10 electrons and s having 2 electrons, so 10 plus 2 12. 12 plus number of electrons present in p subshell. And if it belongs to d block, then its group number is equal to ns plus n minus 1d electrons, because n minus 1 is which number is present, like if it is 4d or it is 5d, so will minus 1, so 4 minus 1 is equal to 3d. So with example it will be more clear to you. So these are rules to find out group number for s block, for p block, for d block. Now we'll start. Suppose we have to give atomic number 15. So first of all you will write electronic configuration 1s2 2s2 2p6 3s2 3p3. We'll count number of electrons 2 to 4 and 6 10 to 12 and 3 15. So now see here, last electron enter into p subshell, so its block is p, and period is, which one is the highest number here? 3, so it means its period is third. Now it's p block elements, so we'll follow this formula, that 12 plus np electrons. So I have written here 12 plus how many number of electrons are present in p subshell? 3. So 12 plus 3, it is 15th group element. If you remember, Z15 is present of which element having atomic number 15, that is phosphorus. Its atomic number is 15 and it belongs to group 15. First nitrogen, then comes phosphorus. It belongs to nitrogen family. So it's a very simple method. Again I'll discuss it with you. Suppose we have given atomic number 15. First we'll write electronic configuration, then we'll see last electron enter into which subshell. So you can see here it belongs to p block. So we'll write here block is p, and highest n number is here 3, so that is period number, that means it belongs to third period. And group number is, because it's p block elements, and then we'll apply formula 12 plus number of p electrons. 12 plus how many number of p electrons are there? 3. So I have written here 3, so 12 plus 3, it's group number 15. It's very easy and very simple method. I'll give you some shortcuts also how to find out the position of element with greater atomic numbers. It's a very easy topic and very important topic also for both NEET, JEE and for CBSE exams. So next comes, if Z is 19, then it is potassium. It belongs to last electron enter into 4s1. So block is, because it's enter into S subshell, so its block is S block, and highest number is here 4, so period is fourth period, because it's belong to S block. And how many number of electrons are present in S? Only 1. So I have written here group is equal to number of S electrons, so only 1 electron is present in S subshell, so it means it's first group element. Obviously its atomic number is 19, so it's belong to lithium, then sodium, potassium, then it's rubidium, cesium and francium. These all are group 1 elements. I hope it's clear. We'll do some more examples, like if Z is equal to 25, I'll see last element belongs to enter into D subshell. It means its block is D, and highest number is here 4, so period belongs to 4th group number now, because it's D block element, so its formula is NS plus N minus 1D. Sorry, I have written here plus, it's come here N minus 1D electrons. So how many number of S electrons are there? 2, and number of D electrons are 5, so 2 plus 5, it's belong to 7th group. Again listen, it's D block element because last electron enter into D subshell. So I have written here block is D block, period highest number is 4, so its period is 4th one, and for its group will write formula NS plus N minus 1D electrons. So see here how many number of S electrons are there? 2, and number of electrons in D subshell is 5, so we'll plus them, sum up them, so it comes out to be 2 plus 5, its group is 7th. Same way you can write, if Z is 40, we'll write its electronic configuration. You can write noble gas configuration also, and see here last electron enter into D subshell, so its block is D, and highest number is 5 here, so it means its period is 5. Because it's D block element, again we'll apply this formula, that is NS plus N minus 1. I don't know why I have written everywhere plus sign. So how many number of S electrons are? 2, D are 2, so 2 plus 2, 4. So it's a 4th group element. 4th group comes in transition series, because 1 and 2 they are S block elements, then 3 to 12 they are D block, they are also called as transition elements. So this one is element of 4th group and its class is transition element. Same way I have written with atomic number 54. Try to do it yourself. And here I have written when Z is equal to 74, so you can write its nearest noble gas configuration, xenon, whose atomic number is 54, 4F14, 5D4, 6S2. Or I have written here shortcut to find out block and period. You can see its last electron from D subshell, that means it's D block element, and highest number is 6, so its period is 6th. Its group is, because it's D block, so we'll sum up S and D electrons, so it's 4 plus 2, 6, so it belongs to 6th group. It's also a transition element. Now here I have written some shortcuts. With these shortcuts you can easily find out that particular element belong to which block, which group and which period. Shortcut number 1 I have written, if atomic number is from 58 to 71. So 58 to 71 comes lanthanoids, because lanthanide starts from 57 till 71. So these are lanthanoids. So you can write easily that they belong to F block. Their group is 3rd and period is 6th. For example, I have written here, if Z is 56, so you will write here noble gas configuration, that xenon 54 6s2. Now its block is S, and S having 2 electron each, so it means it's a 2nd group element, and highest number is 6, so its period is 6. So it's very easy to learn with these shortcuts. Second shortcut I have written for actinides from atomic number 90 to 103. They belongs to actinides. Their block is F, their period is 3rd, and their group is 3rd and period is 7th. They belong to 7th period of the periodic table. For example, I have written here, if Z is 65, so that lanthanide I have written here. Also I have written lanthanide, that is 70. No, these are actinides. If Z is 78, they are not actinides, they are example of 10th group, that is D block element. Next shortcut, I'll give you example of actinides also. So next shortcut is when Z is 11 to Z17, learn this configuration, that neon 10, 3s and 3p. Next from Z19 to Z35, argon 18, 4s, 3d, 4p. With the practice it will clear to you. If you will try to do it today only, that it seems to be difficult for you ki what ma'am has written, we are a little bit confused in it, but later on as you will do practice again and again, then these shortcuts will definitely help you. So I have written shortcut for atomic number 55 to 85, 87 to 117, 117 to 168 and so on. Here I have written example for Z114. So it's, you can write radon 86, 7s2, 4f40, 5f14, 6d10, 7p2. So now last electron enter into p block. It means it's p block element, highest number is 7, so its period is 7th because it's p block element. So we'll write group 12 plus number of elements in p block, so it's 12 plus 2, it's 14th group element. It's which element? It belongs to 14th group. I hope that is clear to you. Do practice yourself. Then if any problem arises, then any time you can call me and you can ask. Now this one, this you have already done in your class, that nomenclature, IUPAC nomenclature system for atomic number more than 100. I have written in tabular form that digit present in atomic number, then their numerical root, then their abbreviation. It's from 0 to 9. They have written their numerical root also. For 0, nil. For 1, it's un. For 2, bi. 3, tri. 4, quad. 5, pent. 6, hex. 7, sept. 8, oct. 9, in. With their symbols I have also written. First word is their symbol. So if we have to find out symbol for atomic number 106, so I can write it easily while writing like this way, 106. So one symbol is its numerical root is UN. So I have written here UN. For 0 it's a nil. For 6 it's a hex. So un, nil, hex. We have to then add suffix IUM to these all numerical roots. So its name will become un plus nil plus hex plus IUM. It's un-nil hexium. It's un-nil hexium, and its symbol is, for un it comes U, for nil it's N come, and for hex it's H. So its symbol will become UNH. Second is, if atomic number is 113, so for 1 it's un, again 1 un. For 3 it's tri, so we'll write it's un tri IUM, trium. So its symbol is UUT. So that's all about for IUPAC nomenclature. Now here are some key features of modern periodic table. You will have to learn all these are very, very important points I have written for modern periodic table. Typical elements, they belongs to period 2 and 3, means they have their own properties. They are called as typical elements. And bridge elements, they are belong to period 3. They are bridging between two periods, so they are called as bridge elements. They show properties of both. Representative elements, they are belong to S and P block element. Transuranic elements are those whose atomic number is more than 92. Most abundant inert gas on earth, that is argon, and most abundant inert gas in universe is helium. Most abundant gas in atmosphere is oxygen, and most abundant metal in earth crust is aluminium. Noble metals are gold and platinum, and highest melting point among non-metals is carbon. Highest melting point among metals, that is tungsten. Highest density is of osmium and iridium. Lightest density is of hydrogen. Liquid elements are two, that is mercury and bromine. Most poisonous element is plutonium, whose atomic number is 94. And metal which is present in hemoglobin is iron. Metal present in chlorophyll is magnesium. Best conductor of heat and electricity is silver and copper. Worst conductor of heat and electricity is sulfur. And coinage metals we have already discussed with the configuration that copper, silver, gold and lead. Means when currency was not here, then in past certain metals are used for coins, so those are called as coinage metals. So all these metals are used for making coins. Thank you.